Let g of x equals x times e to the kx, where k is a constant. For what value of k does g of x have a critical point at x equals 1? All right, so critical points exist when g prime of x is going to be equal to 0. So that's what we need to deal with first. Since g of x is x times e to the kx, this is going to involve product rule. Product rule is u prime v plus v prime u. So what I need to do is find out if I label u as x and if I label v as e to the kx, u would be x, v would be e to the kx, right? U prime is 1. V prime is going to be, take the derivative of the outside stuff, which is still just e, because the derivative of e to the whatever is e to the whatever. Keep the inside, which is kx. But since k is a constant, multiplying everything by the derivative of the inside would be me like taking the derivative of 2x or 4x, which is 2 or 4, or in this case, k. So now, g prime of x is going to equal u prime v, so 1 times e to the kx, plus v prime, so k, e to the kx, times u, which is x. So let's clean this up a bit. E to the kx plus k x e to the kx. Now, g prime of 1 has me substituting 1 for every x. So e to the k times 1 plus k times 1 e to the k times 1. So e to the k plus k e to the k. Now I want to set g prime of x, or now g prime of 1, equal to 0. So let's set u equal to 0. I have an e to the k in common with both. Okay, so let's factor out an e to the k, and that leaves me with 1 plus k. Now you use the zero product property and set this up as two separate equations, all right? E to the k equals 0, and 1 plus k equals 0. Well, what value of k, if I were to use it as an exponent, would get me 0? Nothing. This is exponential. There's no number that will, if I were to plug into k, would get me 0. It's impossible, so you're an impossibility. This guy, all I have to do is just subtract 1 from both sides, and k equals -1, which is going to give me b. So a very, very, very bizarre problem. Very bizarre problem, but that's how you would do it.